Welcome to a new test and teardown video. This one is another Tektronix scope, type 515A. It's a one-channel oscilloscope, and it's very, very similar to the 317 I just released a video about as well. All the knobs, all the features, everything is even located the same place and all that kind of stuff. I was just doing a little wash and clean before I started the video. I like my stuff to look a little bit beautiful on the video. So what I did is I took away all this and washed it real nice and beautiful. So just before I put everything together, I just wanted you to see how it's made, with little rubber thingies and big hefty screws. And then there's a little plastic insert here that goes all the way around the tube like that. And then the bulbs, they stick a little bit out. And there's a funny little piece of plastic that is like that. So when you turn that screw, you can adjust this around. And I think there is a pretty good idea. Because look what happens when I try to... Oh, let me see if I can assemble this without breaking anything. I only got one. Oh, hang on a second. So I got it. So the fine adjustment here is obviously for up and down, right? Because it is completely locked on the 4 screws, this piece of plastic. But look at that, it's symmetric in the design. So that means you can choose between the way that this is looking, right? Or you can have it upside down if you want. It's all up to you. And then you put the little rubber thingies on here, and then we go. Anyway, so this tube is, or this oscilloscope is an all tube product. Actually, it contains 33 tubes. And it's from 1957 to 1971. And it consumes 275 watts. At least that is what the manual says. So while I was doing a lot of cleanup here, I'm of course also inspecting all the knobs. Are they moving? And all that kind of stuff. This one goes a little bit sticky. And all that is perfectly. This one I need to deal with. This click is super tight. And this one goes nice. But here's one. This one I can't move at all. So I need to open this and see if I can handle that before I power it up. I think I want to do it that way. Oh, by the way, I said this was a single channel oscilloscope, but look, we got 2 inputs. So you could like really fast switch between 2 inputs in your circuit. It goes AC, and then DC. So that means it's super fast just to check. Oh, this one, there's one, this one, that one. So I mean, here is your alternating mode. Oh, that is so cool. But this is a cheap and way, and actually quite useful way to solve a problem before they made 2-channel oscilloscopes. So it's not that stupid, really. Sometimes I'm just getting old and soft and careful about stuff. So let's inspect and investigate before we power this up, because I really don't want to blow it up or do anything smelly dumb stuff like I did with the 317 I just played with. So now I'm going to do a much deeper tube investigation. So I'm looking for wide tipped topped tubes, and they are all nice, like that. But what the heck is that gross stuff? And it's also in here. Super gross. What exactly is going on? And that is the delay line, by the way. Exactly the same design as the 317. Power supply, the high voltage power supply is very different in this model, but all the other power supplies and the rest of the circuits, that's more or less a steal from the 317, or it's probably the other way around, because the base design of this one is actually older, right? That is the right side of the scope. And again, I really want you to see the 317 video as well, because what you see here is more or less just a size up copy of that scope. They're just very identical. And that is, of course, the high voltage stuff we need to go and have a look in. I see a little bit of the high voltage rectifiers down there and a little melted wire. Oh, by the way, this is the original silver solder wire. You're supposed to use this silver solder. Oh, look here, it even says here on the ceramic. Okay, so this is important. See the instruction manual. All right, we're gonna go and have a look in here as well. And I didn't find any very blown up tubes. We got a little bit bigger rectifier diodes in this one, but they are actually located exactly the same place. That will be, let me get some light. That will be the tubes for the high voltage, the oscillator and the regulator tubes. And in here is the high voltage switch mode transformer. And that is the calibration oscillator right here. I see some really funny stuff going on in here in the high voltage supply. I see a little plastic bag with some stuff, and there's actually some notes written on this. So I better open up here and have a look what is going on. So I'm really happy that I'm doing investigations before I power up stuff. Also, I really need to clean up this. What the heck is that, really? So I took away the two lids, like that one, and the other one here for the high voltage, also to get access to the little bag here of capacitors. And those three capacitors here, there's actually this, and that one. And there's a nice little note that goes here. It says those capacitors is most likely not defect. They were replaced by nostalgic reasons. And there's also another note here about the ECC 8212AU7 V710. It needs to be good. Otherwise there is some problems with the high voltage. And it sounds like an arc in some of those capacitors and stuff, especially when the oscillator starts again. So that is something we need to be careful about, and that is of course 710. I don't know if you can read that down there. See, it says 710. So it's that one up here, and this is the tube for the high voltage. So this is something I will definitely listen for. So that was a good Note, and it says here that the original in the back they were this, and they were replaced by 2 times 4.7 instead of this. Nice. So I'll definitely keep these, or I will put it back exactly as was this node and that capacitor. Oh, by the way, in my 317 that resistor gets very warm and the other two don't get warm, so I look forward to see if that is also the case. But before I power this up, I need to carefully clean out all that mess. So, clean up time. Let's look at the bottom as well. And by the way, if you're not familiar with the Tektronix screws here, they look like screws from the outside, but all you have to do is just turn them 2 times, then they get loose, and then this little plastic things just moves a little bit around, and then you can open it like that, and then it's stopped like that. And when you want to tighten it, it starts to go this way, and then you tighten, and then it goes and press everything here. So that is all you have to do. If you do it the other way around, just screw, 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 then it's gonna fall out and get lost somewhere, right? And then you also need to figure out how to put this back again, because sometimes you'll see more than one hole, and that is because this is not the case with this one, but it can be on symmetric sides or stuff like that, then they can be in more than one place, right? So let's look in the inside here. Still this really ugly stuff here I need to fix, but other than that, it's really, really nice and beautiful. Big bad main transformer. Oops, that is what I heard, because I heard this when I transported the damn thing. So this is of course something I need to fix. See, this one could go down and potentially short stuff here, so that was good. I found that one. It's, again, look how important it can be to do a good inspection before you just power up stuff. That way you'll save yourself a lot of problems. That is a lot of cleanup here with my brush. So I'm brushing everything here and cleaning everything up, and of course also fixing this loose one, tightening a little bit and giving it a little bit of my green lock varnish. Look at all that. So this is all this stuff, and look what that is. It just turns itself into powder. I think this is some sort of a cork. More or less the same material as this kind of cork, right? And then it was around here, if you look in here. So there was a ring of this that was just way too long under here, where they tightened this one and to hold the tube. And all this stuff that sticks out kind of just crumbled up and got all crusty. Alright, I think we're ready to power this up for the first time. So I'm getting ready to power this up. And this is the mains cable that was supplied with the unit. And of course this plug actually still works. I believe this is the original one, so it's what, about 60 years old, right? But it feels alright here in this end. But the other end, look at that. This is so, there was actually tape around here. This is so loose, it's just falling apart. And this was an adapter of some really, really bad quality. Instead of just cutting off this connector and putting in a proper connector, this wire cable here is just so thick. So before I'm going to power this up, of course I inspected the filter, and this is super big. but it's so clean. I can look all the way through it. Let's get some light here. See? So it's really nice and clean. And also I inspected the fan. Look at that. It just spins really nice. It's always a good idea to take it, lift it up and down, left, right. It's normal, you can go in and out like that, right? But I just wanted to see if there's any sideways slick slack here. Because then the bearings, they're dead. And that is a classic problem with this type of fan. But it seems to be pretty good, and it's also very well balanced, so I am quite happy about that. I do understand this cable is what, more than 60 years old, but how can it get this gross? It is just super dirty and sticky and real gross all over. Look at the thickness. It's so close not to fit into a normal mains connector. It's really that. It's so thick you could pull like, yeah, you can pull a lorry using this cable. And I am of course going to investigate a little bit on the mains transformer before I power this up. And it turns out it is a little bit confusing the way that they numbered here, right? So look at that. 1 and 4. That's always our mains entry. And what I see here is B2 connected together, right? C and 3 connected together. And that one is D and A. I don't know if you can see that A. Now you can see the A. So D and A connected together. This one is 14, this one is 15, and 16 is here, right? So those we don't need to worry about. The problem is the distance the text is located more closer to something else, right? Instead of, yeah, this is confusing. So if I look up the data sheet for in the manual for this transformer wiring, this is 220 volts wiring, but we got 230 volts. So what I need to do is I need to change this a little bit. So here's the manual. 220, 1 and 4, C3, B2, and D and A. That's what I got, right? So this is what I want. And the fan is connected to pin 3 all the time. Doesn't matter, that is half of the voltage anyway. So all I have to do is remove all those 3 shorts and make a new one between 2 and 3. So I believe this should do it. That should be pin 2 and 3. Otherwise it's gonna blow up. I left a little note here for the future. I think this is the moment I've been waiting for the whole day. I want to try and show both the screen and the high voltage section here in the dark. So if there's any arcs or anything that lights up, it should be real fun to see. We can also see the tubes in the high voltage down there. So I don't know if you need to look here or where you need to look. You can also see some of the tubes in there and all that kind of stuff. So I powered up, I turned the scope on. I adjusted everything here so it should be okay. Connected let me show you. I connected the oscillator and the input here. I just take input 2, it doesn't really matter. Like that. I think everything should be more or less ready for a picture. And now I just crank up my mains real slow. I just aim for like 50 volts and then I will see 60 volts, only 20 watts. I see some light up here. Why are they so bright? That is weird. You see up here? We see some neon bulbs. They are very bright up in the high voltage section. And I'm running at 70 volts. That is a little bit weird. Now they're getting dimmer. Okay. They're supposed to be like that. Right. The fan is... Yeah, the fan is going. We are at half supply, 60 watts. Yeah, let's just crank it up now. This is only 100 watts. Yes, we got beam. Look at that. I'm running it at a little bit under voltage. Okay. So we've got a little bit of problems with the triggering. Oh, you can't see any of this. Let me see if I can help you guys a little bit. The beam is in. Where is it? Yeah, here we go. We are definitely alive. Vertical, horizontal, trig is good, intensity is good, focus. Wow, look at that picture. That is nice. Oh, the scale illumination is just so sexy. Look at that. Oi, 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 that is beautiful. Wow, manna, manna. So, okay, trigger is here. But where's auto trig? Where is that? Okay, I am not in auto trig. Now I'm in auto trig, right? See if I... Yes, I am. It was me who was dumb. I need to use this scope right. See this one? That is auto. And I was here. And of course, if level is not right, I don't have a picture. So I was just totally dumb. But that is just a beautiful picture. Ha ha! What a lucky day. And that one is very beautiful. This is not visible on the camera, but it's very, very beautiful, that color. What do you think about that? I've been running a little bit more with this scope, as you can see here. A little test input. I got a little bit of problem with the high voltage supply, and it is actually arcing over somewhere in the high voltage. And you can hear and see what I see. Now I'll try and adjust the high voltage. I'm actually running it a little bit on, I don't know if we can see this here, on under voltage to prevent this arc over. So now I'll try and crank it up a little bit, and then you try and listen. No, it's of course not happening. As you can hear, this is the... Damn it, now it's of course not doing it. But I was hearing some click, 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 clicks, and then the pictures, of course, going up absolutely berserk. So this is definitely what the previous owner was talking about. So I hear this, but I don't know where it's coming from. Damn it. So I need to investigate a lot more. So what you see right here is the high voltage transformer, the switch mode transformer for the high voltage, and this is just a normal oscilloscope, right? 500 millivolts per division. Look at that distance. So of course this is a high impedance input, right? But so now you understand why it is inside a shielded case. If you got a wire or anything inside here that's like high impedance critical stuff, it will definitely be affected by this. And by the way, this is 57 kilohertz of sine wave switch mode oscillation. So if you remember the video I just released about my 317 scope, that is more or less identical. Remember, I was always complaining about that very warm resistor, and again it is exactly the same resistor that gets exactly as hot. Here, here it's 90 Celsius, but of course it is a very big power resistor, but it does indeed get very warm. It's funny, the other two resistors right next to it, they don't really get warm. So, I mean, is that a super good design or what? So I'm looking around the different, see, this looks much more healthy, but I'm looking around the different parts, especially in the high voltage, to see if there's anything weird or warm or stuff going on here, because I haven't still figured out where the funny arc sound is coming from. A new power on sequence from cold, because that is when you hear this arc over. Now, listen carefully. Here. You even saw the blinky of the filaments of the rectifiers. That is interesting. So now we know it is definitely something with the oscillator. In my desperate attempt to find the arc over problem, I've been changing a lot of different components in this high voltage supply. I also been adding a lot of information, as you can see here, so I can navigate around where is what. I changed the rectifier valves to diodes, and over here I've been playing around with all the different capacitors as well, swapping and disconnecting and connecting and doing all sorts of experiments, and it just continue to drive me absolutely nuts. Let's look a little bit on the schematic. So that will be the 3 rectifier diodes are replaced with normal diodes, and that was pretty easy, and that didn't change a lot. It changed, well, a little bit, improved it a little bit, and that is of course because now we don't need to use that much energy for the 3 filaments, and also we get easier a higher output voltage, and then the feedback system will just crank down the primary side energy a little bit, and that is of course better if you are having a arc over problem. I've performed some measurements on the feedback point here at C714, and the normal is minus 165. That is of course correct when it is working, but when it arc over, this voltage goes up 300 volts positive, and then I was thinking, how the heck is that possible? Where is this 300 volts coming from? But there are actually a lot of different ways that is possible. It can go via C722, via our 722, and then we got access to the transformer windings. But it can also go via a pot meter and a resistor to a plus 300 volt. So of course I changed all those components, and it didn't affect anything at all. Also, I've been measuring on V710 all the different sides of the tube, and of course it is very clear that those arcs arc over from the transformer. It can be potentially kilovolts. It is just going through everything. It's visible all over the place. So I'm actually not able to say exactly where it is, but I really suspect the transformer. I've been in contact with quite a few other guys that owns exactly this scope, and it's always the transformer, and they're buying wound transformers, or they're doing it themselves. It's quite a lot of work, and I am not going to do that. I was considering loaning a transformer from my Tektronix 317, but I'm not quite sure it's compatible. It looks a lot like it could be compatible, but I'm a little bit unsure. So I don't want to risk having two dead oscilloscopes. So I think this is going on pause until a future donor transformer is available. I still don't have the shields on, all this high voltage. I've been adjusting the high voltage to like 1300, 1400, and then I don't see any arc over. And it's actually a nice and stable oscilloscope with a really beautiful picture. In some of the modes like this, see, you can see a little bit of ripple here. I don't know if that's easy to see, but that is definitely interference from the high voltage oscillator. I wanted to try and play a little bit with the trigger and see how well the delay line works. Here is my 1 microsecond pulse. It's just super beautiful with this light here. It is probably the most beautiful I have seen in a long time. But you see the rising edge of my 1 microsecond pulse, and but the problem is I am running in 1 microsecond per division. So I mean the time base is nearly 150% too slow, isn't it? So that's a little bit funny, or maybe I'm doing something wrong here, but that is definitely how it appears to be. But I really like that you see the front leading edge like this, and if I just crank it up to its maximum potential, here is 1 microsecond. This should be 0.2 per division, right? So it's like this, right? So this is 1 microsecond. So what is all this? Or am I doing something completely wrong here? I have no clue what I'm doing. This is 1 microsecond. I can of course give you a shorter pulse. So this is 100 nanoseconds, if that is what we want to do. But here the scope says 0.2 on the scale, so I think it is a little bit too slow on the time base. But the delay line definitely works, and it's nice and sharp, and I mean beautiful picture with tons of light, and I'm even running it at under voltage, right? But of course under voltage could also affect the deflection and how well it's scale, and that will always also affect, you know, horizontal and vertical, of course. See, I've been cleaning the pots, so all the and it even triggers on tiny little. That is actually impressive. I was expecting to see all sorts of problems here, but look at that. That is definitely nice. But anyway, I don't have a lot more to say. thank you very much for watching, and I hope you enjoy your Tektronix scopes. Take care of them out there. Bye bye.